We're now going to be looking at trigonometric ratios. This first lesson is about trigonometric ratios of acute angles. This is very much similar to what gets taught in grade 10. The only addition is that now you will become familiar with the reciprocal functions. And reciprocal functions are just what they are. Reciprocals are when you take a fraction and do 1 over that fraction, or basically invert it. So sine theta is the opposite over hypotenuse. Cosec theta is then the hypotenuse over the opposite. Cos theta, adjacent over hypotenuse. Secant theta, hypotenuse over adjacent. Tan theta, opposite over adjacent. Cotan theta, adjacent over opposite. What I do to remember these is sine theta, I might expect in my mind goes with sec, but instead it goes with the opposite to what I would think. So sine theta goes with cosec, whereas the cosine goes with the secant. That's one way you can try to remember it. And then tan and cotan seem very logical the way they're paired up. In this exercise for the minds on, what you will be doing is just becoming familiar with the angles that go with these three ratios. And so you'll be using the inverse button on your calculator or second function button. When you're trying to find an angle, you do the inverse of the ratio, and then what the calculator does is look up the ratio and finds the angle that goes with it. Remember, trigonometry is based on the fact that when you draw a right angle triangle, that whatever angle you have, no matter how large the triangle is, the ratio of the sides to each other remain the same. That's constant. And so we count on the fact that, for example, when you have a ratio of 0.5, the angle of that triangle is always going to be the same. And remember too that when I say the angle, I'm referring to the angle that we're working with. There's a 90-degree in all of these, and then there's two angles that will each stay the same. And because there's already a 90, those other two angles will add up to 90. So what I want you to do is simply get familiar with going through and calculating the angles. I am going to talk to you about doing these ratios here before you get started. With the reciprocal functions, one thing you need to know is that they aren't on your calculator. And so part of the goal is that you would be familiar with reciprocal functions. Keep in mind that when you're doing actual calculations, you will always have to revert back to the three primary trig ratios. We are going to be working with them, and so you will end up doing some extra work that you wouldn't normally do. When you do the inverse tan of cosec theta, remember that it goes with sine. So when you're given 0.15, to calculate this angle, we would have to do the inverse sine of 1 over 0.5 in order to calculate the cosec theta, because they are reciprocals of one another. Here, sec theta goes with cosine, so you would do the inverse cosine of not 0.5, but 1 over 0.5. And for here, you would do the inverse tan of 1 over 0.5. So you see, we still end up having to use the primary trig ratios, but it's getting you familiar with what to do with those other ratios and to know that they exist, the reciprocal functions. So what you should do is go ahead and find the angles for all of these. Again, just a reminder that here then we would be doing the inverse sine of, in the first case, this is for the first row, then the inverse cos of 0.5, and the inverse tan of 0.5, and then you would do similarly for the other two values, 1.0 and 1.5. One thing to keep in mind when you do this table is there are going to be some errors, and that's to illustrate a point. The inverse sine of 0.5 is 30 degrees. Inverse cos of 0.5 is 60 degrees. And then the inverse tan of 0.5 is equal to 26.6 degrees. The inverse sine of 1 divided by 0.5. On some calculators, you may be able to use the fraction button, but a lot of calculators, you can't use the fraction button with a decimal for 1 and possibly with a trig function. So you need to be careful of that, but division will always work. In this case, we do get an error, and we'll talk about that. Then the inverse cos, second function, cos 1 divided by 0.5. And that also gives us an error. And then finally the tan, second function tan 1 divided by 0.5. And that gives us a value, that gives us 63.4. Now at this point, I'm just going to stop and talk about these errors. Remember that the hypotenuse is the largest side. And the trig ratio for sine, cos, and tan are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Tan is the only one that doesn't have the hypotenuse in it. Sine and cos both have the hypotenuse in them in the denominator. And if the hypotenuse is largest, that means that this numerator, the opposite on top, will always be smaller than the denominator. Similarly with cos, the adjacent in the numerator, that number will always be smaller than this hypotenuse. So these ratios will never be greater than 1. And if you look over here, these two ratios are greater than 1. And that's impossible because of the fact that the hypotenuse is the largest side. So you get errors here. But with tan, there's no such relationship. The opposite and the adjacent can be bigger than each other. So there are no tan functions where you do an inverse of the ratio and you get an error, except if you have division by 0. But that's a whole nother story. That's more left to grade 12. Now we'll just go ahead and finish these last ratios. So the inverse sine of 1, second function sine, and now this is the limit that we were talking about. The largest that those ratios can ever be is 1, and the inverse sine of 1 gives us 90. And that should make sense, hopefully, when you think about that, because there's already a 90 in the triangle, and triangles add up to 180. And something else you may be thinking about here is, in reality, if you have two angles that are 90, you don't have a triangle anymore. And so there is one ratio here where the triangle actually doesn't exist, but we still recognize this ratio in terms of the angle that it gives. And then the inverse cos of 1 is 0. And the inverse tan of 1 is 45 degrees. Coming over to the reciprocal functions, once again, we're going to need to do 1 over. And we were working with 1 here. Second function, sine, and this is 1 over 1, so it's just 1. And once again, we get 90. Second function, cos of 1 divided by 1, which is just 1. I'll do the divide just to show you. That gives us 0 degrees. And the second function of tan, 1 divided by 1, which is just 1. And so again, we get 45 degrees. And a reminder that these values that I was doing here, where I used sine, cos, and tan, I did the reciprocal of this ratio. So really, what I was technically calculating was the cosec, sec, and cotan. The last value is the 1.5. Inverse sine of 1.5, and we get an error. And that's a number that's greater than 1, so we would expect an error. The inverse cos, and once again, we will be expecting an error. The inverse cos of 1.5 gives us an error. So that's something you want to keep in mind about the ratios being between 0 and 1 or 0 and -1. And we will get into the negatives in another lesson. Finally, the second function tan, or the inverse tan of 1.5 is 56.3 degrees. Coming over to the reciprocal functions, the inverse sine of 1 divided by 1.5 equals 41.8. So here we don't get an error because 1.5 is in the denominator and it's the largest number. Then the inverse cos of 1 divided by 1.5, that equals 48.1. And the inverse tan of 1 divided by 1.5, that gives us 33.6. What we concluded here about the ratio values for trig functions is that the values must be between 0 and 1. So the values of the ratios for sine and cos must be between 0 and 1. And again, I mentioned that later on we will talk about this also being between 0 and -1, but we will leave that for now. All right, so that's a quick review of the primary trig ratio, sine, cos, and tan. And now our introduction to you of the reciprocal functions. Now, because this is very similar to what you did in grade 10, we do not need to do many examples here. First thing I would like you to do is go ahead now and write all 6 trig ratios for this triangle. Now, in order to do that, you do need the hypotenuse, so we do need to recall Pythagorean's theorem. So what you would do is use Pythagorean's theorem to get this hypotenuse, and a reminder from earlier lessons that we're going to stick with exact values, so we're going to leave any roots that we have without calculating a decimal value so that we have exact values. C is the hypotenuse, so C squared is equal to A squared, or one of the sides squared, plus the other side squared. And that gives us 25 plus, if we square that on our calculator, or you can do it in your head, it would be 100 times squaring this root basically gives us 2. So that would be 100 times 2, which is 200. And that leaves us with C squared is equal to 225. C is equal to the square root of 225. And if you do that, what you will get is 15. So now we know the hypotenuse is 15. Writing the 6 trig ratios, I'm going to label this angle as theta. The sine of theta, remember, this is a name for a ratio of the opposite over the hypotenuse. So the sine of theta is 5 over 15, and reduced, that would be 1/3 because 5 divides into both of them. The cos of theta would be the adjacent over the hypotenuse, which is 10 root 2 all over 15. Reducing that, 5 goes into 10 and 5 goes into 15, we get 2 root 2 all over 3. For tan of theta, we get the opposite over the adjacent, so that is 5 over 10 root 2. That gives us 1, because 5 goes into 5 once, and then 2, 5 into 10 twice, root 2. Now, we need to do something that hopefully you learned in grade 10. Now, we need to do something that we've learned earlier. We don't want a root in the denominator because that's really a decimal value, and denominators of fractions are supposed to be whole numbers. So we need to multiply the denominator by root 2 and do the same to the numerator. And what we end up with is root 2 all over 2 times root 2 times root 2 is 2, so that gives us 2 times 2, which is 4. Now, when we do the reciprocal functions, we could get them from the triangle and simply reverse what we did in this first step. But also keep in mind that if they're the reciprocals of these 3, then we can take our answers here and simply flip them. Basically going to do the reciprocal of this fraction. I'm going to do the first one from the triangle just to help you to think about it that way. Remember that sine goes with cosec. Cosec of theta is equal to the hypotenuse, which is 15, over the adjacent. The hypotenuse, which is 15, over the opposite. That's 15 over 5, which is equal to 3. Or once again, we could have simply looked at its reciprocal here and flip this to get 3 over 1, which is just 3. So for the next two, I will do that. For the secant of theta, which goes with cosine, we have an answer of 2 root 2 over 3. So what we will get is 3 over 2 root 2. Once again, we need to rationalize this, so I will multiply by root 2. And eventually you can just do this in your head, and that's fine. Multiplying, we get 3 root 2 all over 2 times root 2 times root 2 is 2. That undoes the root. 2 times 2 is 4. Cotan of theta is equal to 4 over root 2. Now, one thing I want you to note is if I go back to here before I rationalize this, I had 1 over 2 root 2. So I could take this and do the reciprocal because now my root will be in the numerator, and it turns out that I have 2 root 2 over 1, or simply 2 root 2. And again, this is to get you familiar with these reciprocal functions. Sometimes when we use them, it will seem like extra work, but we really just want to work with them so we're familiar with the relationship. Coming down here, we are going to do 2 review operations here, but we're also going to add in working with a reciprocal. Keep in mind that we're just going to switch the reciprocal function to a primary trig function. So here it says use primary trig. Here it says use a primary ratio and a reciprocal ratio to find the length of the missing side. So what I suggest here is that we start with the reciprocal ratio, because then we'll be using the primary ratio anyhow, and that will save us some extra work. This is our angle, 25 degrees. That's our reference point. So we have the opposite, which has no values on it, the adjacent, and the hypotenuse. So these are the two we need to work with in order to solve for x. So you need an unknown and a known. In any trig ratio, there's an angle and 2 sides. So there's 3 unknowns, so we need 2 of them in order to get the third one. This is the adjacent, and this is the hypotenuse. If you think about this acronym, SOHCAHTOA, sine equals the opposite over the hypotenuse, cos equals the adjacent over the hypotenuse, and tan equals the opposite over the adjacent. In this case, we have adjacent hypotenuse, so that's cos. We said that we're going to start with a reciprocal ratio. The reciprocal function for cos is the secant. So we're going to start with the secant of theta is equal to the hypotenuse over the adjacent. So we have the secant of 25 degrees is equal to 10 over x. Now, in order to do this one, on our calculator, we need to switch this to the reciprocal function, which in this case is cosine. So the cosine of 25 degrees then is equal to x over 10, and then we solve that. In order to do this, we need to get rid of the 10 to get the x by itself. That's opposite operations. We're dividing by 10, so we're going to multiply both sides by 10. X then, which would be on the right-hand side here, is equal to 10 times the cos of 25. That gives us 9.1. So the length of that side is 9.1. So now we've satisfied both of these. We started with a reciprocal function. We had to switch it to a cosine function. We started with a reciprocal function. We had to switch it to a primary function in order to solve it. The last example is to do this now, finding an angle. So this one specifically says use a reciprocal ratio again in order to find the size. So we're going to start with a reciprocal and then switch to a primary. We have the opposite side here, and we have the adjacent. The opposite and the adjacent goes with tan and cotan. So tan is the opposite over the adjacent. Cotan of the angle is the adjacent over the opposite. So the cotan of theta is equal to 12 root 5 all over 13. Now, once again, we need to actually switch to tan. We're just doing this to become familiar with the reciprocal functions. Normally, we would start with tan. So we have 13 over 12 root 5. Now, keep in mind that because this isn't a final answer, I don't need to rationalize this. I can simply go ahead and find out what the angle is using this ratio. Theta then is equal to the inverse tan of 13 over 12 root 5. On my calculator, I will do second function tan bracket 13 divided by bracket 12 root 5. Now, in some calculators, including this one, you wouldn't need the bracket. You can figure out on your calculator whether you need that extra bracket inside around the 12 root 5. It doesn't hurt to have it there. And that gives us 25.8. Now you know what you need to in order to go ahead and work on that practice.